Imagine standing under a night sky so vast it makes you feel both small and infinite at the same time. Now picture this. Somewhere out there, entire galaxies are not just drifting aimlessly, but moving with purpose, pulled by something we cannot see. What could possibly be strong enough to command the motion of these colossal structures? Is it a force from beyond our universe, a hidden cosmic giant, or something even stranger? This is the enigma of dark flow, a phenomenon that challenges everything we think we know about the universe. Over the next few minutes, we're going to journey through 25 cosmic mysteries that will stretch your imagination and deepen your understanding of the cosmos. From strange movements in the universe to the secrets hidden in the echoes of the Big Bang, we'll explore how science is unraveling these puzzles while leaving room for wonder. So buckle up, because the universe has more surprises in store than you ever imagined. As we dive into the first layer of this cosmic puzzle, let's rewind to 2008, when astronomers stumbled upon something truly bizarre. Using data from NASA's Wilkinson microwave anisotropy probe, they noticed that galaxy clusters' massive structures made up of hundreds or even thousands of galaxies were moving in a synchronized way. But here's the kicker: their motion didn't align with the known forces of gravity in the universe. It was as if some invisible hand was pulling them toward a specific region of space, far beyond anything we can observe. This strange coordinated drift came to be known as dark flow, and it left scientists scratching their heads. Could this be evidence of something lurking beyond the edges of the observable universe, or was it simply an error in the data? The debate was fierce. Some researchers argued that this was a breakthrough pointing to structures or forces we couldn't yet comprehend, while others dismissed it as a statistical anomaly. What's fascinating is that this wasn't just a minor blip. It was a pattern seen across hundreds of millions of light years. The implications were staggering, suggesting that our understanding of the cosmos might be missing some crucial pieces. And while skepticism remains, the possibility that dark flow could rewrite the rules of cosmology continues to fuel curiosity and exploration. Now that we've set the stage for this enigmatic discovery, let's zoom in further to uncover what might lie beyond the boundaries of what we can see. As we venture further into the uncharted territories of the cosmos, the mysteries only seem to deepen. Picture this: what if the universe we see is just one small piece of a much larger puzzle? That's exactly what some scientists are beginning to suspect. Beyond the edges of our observable universe lies a realm of endless possibilities, and dark flow might just be the first clue. Could it be evidence of colossal structures far larger than anything we've ever imagined, pulling galaxies toward them with an irresistible gravitational force? Some researchers propose the existence of what they call a cosmic tugboat, a hypothetical structure so massive that it could influence the motion of entire galaxy clusters across unimaginable distances. This idea sounds almost like science fiction, yet it's grounded in real scientific models, even if we can't directly observe it. But wait, there's more. The concept of the multiverse takes this mystery to a whole new level. Imagine a reality where our universe is just one bubble floating in a sea of other universes, each with its own laws of physics. If these neighboring universes interact with ours, they might leave subtle traces, like ripples on the surface of a pond. Could dark flow be one of these traces, caused by the gravitational pull of a nearby universe? While this idea sparks excitement, it also raises caution. Scientists know that extraordinary claims require extraordinary evidence, and so far, the data is far from conclusive. Another intriguing angle is the idea that these forces originate from regions we simply can't see. Think of it like standing in a dense forest, unable to see the mountain just beyond the trees. The tools we currently have might not be enough to reveal what's truly out there. This limitation leaves room for bold theories, but also underscores the importance of humility in science. After all, every great discovery starts with a question, and dark flow has certainly given us plenty to ponder. With these possibilities in mind, let's now turn our attention to how this phenomenon might connect with the universe's most elusive components, dark matter and dark energy. Now that we've set the stage with cosmic tugboats and multiverse musings, it's time to delve into the invisible architects of the universe, dark matter and dark energy. These enigmatic forces make up most of the cosmos, yet their true nature remains one of science's greatest puzzles. When it comes to dark flow, they might hold the key to understanding why galaxies are drifting in ways that defy expectations. Let's start with Mystery 7 and the gravitational whispers of dark matter. Imagine an invisible hand reaching out from beyond the edges of what we can see, gently pulling galaxies along its path. Some scientists theorize that this could be the work of dark matter, massive halos of it, lurking just outside the observable universe. These unseen structures might exert a gravitational influence strong enough to cause the coordinated movement we call dark flow. But here's the catch: if this dark matter exists beyond our cosmic horizon, how can we ever prove it? It's a tantalizing idea, but one that leaves researchers with more questions than answers. Next, let's shift gears to Mystery 8, where dark energy enters the picture. While dark matter's gravity pulls, dark energy is known for pushing, driving the universe's expansion at an ever-accelerating pace. Could it also play a role in speeding up dark flow? Picture a river flowing downhill, with dark energy acting like an extra burst of current propelling it forward. If true, this would mean dark flow isn't just a passive drift but an active process fueled by the same force that's stretching the fabric of space itself. However, pinning down dark energy's exact contribution is no small feat. Its effects are subtle and intertwined with other cosmic forces, leaving scientists to sift through layers of complexity. Finally, Mystery 9 takes us into the realm of speculation and challenge. While these ideas about dark matter and dark energy are fascinating, they remain just that, ideas. We lack the hard evidence needed to confirm or refute them, and this highlights a broader issue in cosmology. Our current models, as advanced as they are, may not be equipped to fully explain phenomena like dark flow. Are we missing something fundamental about how the universe works? It's a humbling thought, but also an exciting one. After all, the best discoveries often come when we push the boundaries of what we think we know. With these mysteries swirling in our minds, it's clear that dark flow isn't just a standalone puzzle, it's deeply connected to the larger cosmic web. And yet, the deeper we dig, the more questions arise. What if the answers lie not in distant forces, but closer to home, within structures we've known about for decades? To explore that, we'll next turn our attention to the Great Attractor region and the role it might play in this grand cosmic drama. As we shift our gaze from the invisible forces of dark matter and dark energy, let's bring our attention to a region of space that has long captivated astronomers, the Great Attractor. This colossal gravitational anomaly, nestled near the Laniakea supercluster, pulls entire galaxies toward it like a cosmic magnet. Mystery 10 poses a fascinating question. Could the Great Attractor be the driving force behind dark flow? Imagine a massive, unseen whirlpool in space, tugging galaxies along its currents. Scientists have mapped its influence, but whether it's strong enough to explain the vast, coordinated movements we see remains hotly debated. While it's a tantalizing possibility, the Great Attractor's reach might not stretch far enough to account for dark flow's scale, leaving us to wonder if something else is at play. Venturing deeper, Mystery 11 introduces a twist. What if there are other attractors hiding just beyond our ability to detect them? Picture this. In the same way early explorers once thought the horizon marked the edge of the world, our current observations of the universe might only scratch the surface of what's out there. Some researchers speculate that additional, even larger attractors exist beyond the Great Attractor, perhaps within regions of space we can't yet observe. These hypothetical structures could exert gravitational forces powerful enough to influence galaxies across immense distances. But without direct evidence, these ideas remain speculative, sparking lively discussions among scientists about the limits of our cosmic map. Finally, Mystery 12 takes us into uncharted territory. What if dark flow isn't caused by known attractors at all? This possibility opens the door to even more exotic explanations, from interactions with unseen dimensions to the remnants of ancient cosmic events. Consider the idea that galaxies might be responding to forces we can't yet comprehend, like echoes from a time before the universe as we know it began. It's a bold and controversial notion, but one that underscores the vastness of what we have yet to understand. By challenging our assumptions, Mystery 12 reminds us that some of the universe's greatest secrets might lie not in what we see, but in what remains hidden. With these mysteries in mind, it's clear that the Great Attractor and the broader debate surrounding attractors offers no easy answers. Instead, it deepens the intrigue, pushing us to explore even further. But what if the clues to dark flow aren't tied to gravity alone? To uncover more, we'll next peer into the faint afterglow of the universe's beginnings, where anomalies in the cosmic microwave background might hold the next tantalizing piece of the puzzle. As we turn our attention to the faint glow left over from the universe's infancy, we find ourselves peering into one of the cosmos' most intriguing relics, the cosmic microwave background. This ancient light, a snapshot of the universe just 380,000 years after the Big Bang, holds clues that might illuminate the mystery of dark flow. Mystery 13 invites us to examine a peculiar feature known as the cold spot, a vast region in the cosmic microwave background that appears unusually cooler than its surroundings. Some scientists propose that this cold spot could be linked to dark flow, perhaps as a result of an enormous void or an entirely different cosmic structure tugging at the fabric of space. Picture an invisible hand pressing against the universe, leaving behind a faint fingerprint in the form of this chilly anomaly. While the idea is compelling, the connection remains speculative, inviting further investigation into this cosmic oddity. Moving forward, Mystery 14 delves into the subtle temperature fluctuations scattered throughout the cosmic microwave background. These minute variations, often compared to ripples on a pond, are thought to reflect the distribution of matter in the early universe. But what if these ripples are more than just echoes of the past? Some researchers suggest that certain fluctuations might point to hidden structures lurking beyond the observable universe. Imagine these anomalies as cosmic breadcrumbs, hinting at the presence of massive formations that we cannot yet see. These hidden giants could theoretically exert gravitational forces strong enough to influence galaxies across unfathomable distances. While this idea is still in its infancy, it opens up a realm of possibilities for understanding the forces shaping our universe. Finally, Mystery 15 confronts the heart of the matter: why these anomalies in the cosmic microwave background continue to baffle scientists. Despite advanced telescopes and sophisticated models, definitive answers remain elusive. The cold spot and temperature fluctuations raise more questions than they answer, fueling speculation about everything from parallel universes to flaws in our current understanding of physics. Consider the frustration of piecing together a puzzle when some pieces are missing or don't fit as expected. This is the challenge scientists face as they grapple with these enigmatic signals. Without concrete evidence, the anomalies remain tantalizing hints of something greater, urging us to keep searching for the missing pieces of the cosmic puzzle. With these mysteries in mind, it's clear that the cosmic microwave background is more than just a relic of the past. It's a treasure trove of clues waiting to be deciphered. Yet, the more we uncover, the more questions arise, reminding us that the universe is far from revealing all its secrets. As we continue our journey, let's shift our focus to a particularly intriguing idea, the Dipole Repeller hypothesis, which might offer a fresh perspective on the forces driving galaxies across the cosmos. Stepping into a fresh perspective, Mystery 16 invites us to explore a captivating idea that flips conventional thinking on its head, the Dipole Repeller hypothesis. Imagine a massive void in space, not pulling like gravity usually does, but instead pushing galaxies away with an invisible force. This repeller, unlike anything we've seen before, may hold the key to understanding why vast clusters of galaxies appear to drift toward one part of the universe. Scientists believe this void creates a sort of cosmic imbalance, where galaxies are nudged away from the emptiness and toward denser regions of the cosmos. It's as if the universe is trying to fill a gap by moving everything around it. Through advanced computer simulations, researchers have visualized this phenomenon, showing how galaxies might flow in response to this repulsive force. These models reveal intricate patterns of movement that align eerily well with what we observe in dark flow, making the hypothesis both compelling and controversial. While some experts embrace this idea as a groundbreaking shift in our understanding of cosmic dynamics, others remain cautious, pointing out that direct evidence is still lacking. The debate continues, but one thing is clear: this unusual concept challenges us to rethink how the universe organizes itself and pushes the boundaries of what we know about gravity and motion. With a dipole repeller hypothesis in mind, we begin to see how empty spaces might shape the cosmos just as much as the stars and galaxies themselves, setting the stage for our next mystery tied to another colossal void. As we journey deeper into the cosmic web, Mystery 17 brings us face to face with another colossal enigma, the KBC Void. This isn't just any empty space, it's one of the largest voids ever identified, stretching an unimaginable distance across the universe. To put it into perspective, this void is so vast that it could swallow billions of galaxies without breaking a sweat. But here's the fascinating twist: despite being empty, it might have an outsized influence on the motion of galaxies around it. Scientists believe that such enormous voids can create what's known as a gravitational imbalance. Think of it like a seesaw where one side is almost completely weightless. The heavier side, filled with galaxies and clusters, pulls everything toward it, while the void, with its lack of mass, essentially leaves its surroundings unbalanced. This imbalance could, in turn, drive cosmic drifts, large-scale movements of galaxies that align with the patterns we associate with dark flow. Could this void be acting as a silent puppeteer, tugging at the strings of the universe? Researchers are actively exploring this possibility, running simulations to understand how such voids might shape the grand flow of galaxies. Some suggest that the KBC Void, by virtue of its sheer size and emptiness, could exert an indirect but powerful influence on the cosmic stage. While definitive answers remain elusive, this exploration underscores the profound interconnectedness of the universe. Even the absence of matter, it seems, can shape the destiny of everything else. With this revelation, we start to see how the universe uses both presence and absence to choreograph its grand ballet, leading us toward yet another compelling mystery in the cosmic tapestry. As we shift our gaze from the vast emptiness of the KBC Void, the cosmic narrative takes a turn into the microscopic yet equally awe-inspiring realm of quantum physics. Mystery 18 beckons us to ponder a truly mind-bending question. Could dark flow be the universe's way of revealing quantum effects on a grand macroscopic scale? Imagine spacetime itself as a bubbling cauldron of tiny, fleeting events, quantum fluctuations that ripple through the fabric of reality. Scientists speculate that these minuscule phenomena might somehow amplify across unimaginable distances, influencing the motion of entire galaxies. It's as if the smallest ticks in the universe's clockwork could echo loudly enough to steer colossal structures through the cosmos. Could this be the hidden mechanism behind dark flow? Mystery 19 invites us to take this idea even further. What if these quantum fluctuations don't just ripple through space-time but actively interact with the large-scale structures of the universe? Picture a quiet pond disturbed by a single drop of water. The ripples spread outward, subtly shaping everything they touch. Similarly, quantum effects might cascade upward, nudging galaxy clusters and superclusters into the coordinated movements we observe. Researchers are working tirelessly to test this hypothesis, using advanced simulations and cutting-edge theories to bridge the gap between the infinitesimally small and the unimaginably vast. Finally, Mystery 20 challenges us to consider the bigger picture. If dark flow truly stems from quantum processes, it could hold the key to one of science's most elusive goals, reconciling general relativity, which governs the cosmos, with quantum mechanics, which rules the subatomic world. These two pillars of modern physics often seem at odds, but dark flow might offer a rare glimpse of common ground. Could the universe be sending us a message, written in the language of both the very large and the very small? As scientists delve deeper into this mystery, they're not just solving cosmic puzzles, they're inching closer to a unified understanding of reality itself. And with that, we prepare to venture even further toward ideas that blur the lines between science and speculation. As we journey deeper into the cosmos, the boundaries between science and imagination begin to blur, opening the door to realms that challenge everything we think we know. Mystery 21 invites us to consider a mind-expanding possibility. What if the phenomenon of dark flow isn't confined to our universe alone? Picture this: our universe might exist as just one of many, floating like a bubble in a vast multiverse. According to string theory, these universes could exist on separate branes or membranes within higher dimensional space. Now imagine these branes brushing against each other, their interactions creating ripples that stretch across unimaginable distances. Could such encounters be influencing the movement of galaxies in our own universe? It's a question that pushes the limits of our understanding, yet it's grounded in serious scientific exploration. Researchers are piecing together models to test whether these inter-brain interactions could explain the mysterious pull of dark flow, offering a glimpse into a reality far stranger than fiction. Turning to Mystery 22, we explore an even bolder idea, one that takes us back to the very beginning of everything. What if the seeds of dark flow were sown during the birth of our universe, not through internal processes but through a collision with another universe? Imagine two parallel universes colliding in the fiery chaos of the Big Bang, their impact sending shockwaves through space-time that still resonate today. These echoes could theoretically manifest as the coordinated motion of galaxies we observe now, suggesting that dark flow is a relic of an ancient cosmic event. While this theory remains speculative, it underscores the profound implications of such ideas. If true, it would mean that our universe bears the scars of its interactions with others, a testament to a past we can barely comprehend. These concepts may stretch the limits of what we consider possible, but they also remind us of the infinite potential for discovery that lies just beyond the horizon. And as we move forward, we'll find ourselves questioning not just the nature of our universe, but the very fabric of time and causality itself. As we pivot from the idea of cosmic collisions and multiversal interactions, let's step into a realm where time itself becomes a mystery to unravel. Mystery 23 invites us to confront a startling possibility. What if dark flow is hinting at a universe with a sense of direction? Imagine space-time as a vast ocean. Conventional wisdom tells us this ocean is the same in every direction, smooth, uniform, and without bias. But what if dark flow suggests otherwise? Picture galaxies drifting not randomly, but as if pulled toward a cosmic North Pole, a preferred direction embedded in the fabric of the universe. If true, this challenges one of the cornerstone principles of cosmology, the idea that the universe is isotropic, or the same in all directions. Scientists are now grappling with the implications. Does this mean the universe has an inherent bias, a hidden axis that guides motion on a grand scale? Or is this merely an illusion created by forces we have yet to comprehend? It's a question that forces us to rethink the very nature of the cosmos. Now, let's delve into Mystery 24, where things get even more intriguing. What if dark flow doesn't just challenge the direction of the universe, but also the flow of time itself? Time, as we experience it, moves in one direction from past to future, a concept physicists call the arrow of time. But imagine flipping that notion on its head. Could dark flow be disrupting this orderly progression, creating ripples that affect how events unfold across the universe? To make this idea more tangible, consider a thought experiment. Imagine two observers, one near the source of dark flow and another far away. If the pull of dark flow influences space-time in unexpected ways, could these observers experience time differently? Could one see the future while the other remains stuck in the past? These questions aren't just scientific, they're deeply philosophical, probing the boundaries of how we perceive reality. While we don't have definitive answers yet, these mysteries remind us that the universe is far more intricate and mysterious than we ever imagined. And as we prepare to uncover the ultimate fate of dark flow, we're left wondering, could these anomalies rewrite the rules of existence itself? As we approach the final frontier of our cosmic exploration, we arrive at Mystery 25, the ultimate fate of dark flow. This is where science fiction meets scientific theory, and the stakes couldn't be higher. What does the future hold for this enigmatic phenomenon? Will dark flow persist indefinitely, pulling galaxies toward an unknown destination? Or is it a harbinger of something far more profound, a signal of the universe's ultimate end? Picture this: over trillions of years, galaxies drifting farther and farther apart, stars burning out, and the cosmos plunging into an icy stillness. This scenario, known as the Big Freeze, paints a bleak yet fascinating picture. In this vision of the future, dark flow could represent the last remnants of motion in an otherwise frozen universe, a faint echo of cosmic activity in the vast silence of space. But that's not the only possibility. Some theories suggest that unknown forces might one day reverse this flow, pulling everything back together in a dramatic event often called the Big Crunch. Imagine the universe folding inward, reversing its expansion and collapsing into a singularity, possibly sparking another Big Bang. It's a cycle of creation and destruction on a scale that's almost impossible to comprehend. And then there's the wild-card forces or dimensions we haven't even discovered yet. Could dark flow be the key to unlocking these mysteries, offering a glimpse into realms beyond our current understanding? With each new discovery, we're reminded just how much we still have to learn. As we close this chapter of cosmic inquiry, the question remains: what lies ahead for our universe and the mysterious pull of dark flow? The journey is far from over, and the answers may redefine everything we thought we knew about existence itself. What do you think the future holds? Share your thoughts in the comments below, and don't forget to subscribe for more mind-bending explorations of the universe. Hit the notification bell so you never miss an update, and keep gazing upward. The secrets of the cosmos are waiting to be uncovered. As we bring this cosmic journey to a close, let's take a moment to reflect on the vast tapestry of mysteries we've explored. From the initial discovery of dark flow to the mind-bending possibilities of parallel universes and quantum gravity, these 25 enigmas have challenged our understanding of the universe and our place within it. Each mystery, like a piece of an intricate puzzle, offers a glimpse into the workings of the cosmos, yet so much remains shrouded in uncertainty. Is dark flow truly a window into the unknown depths of the universe, or is it a riddle waiting for the right minds to unlock its secrets? The answers may lie just beyond the horizon of our current knowledge, beckoning us to keep searching, questioning, and exploring. So, what do you think? Is dark flow a key to unraveling the universe's greatest mysteries, or is it something even more extraordinary? Share your thoughts in the comments below. I'd love to hear your take on this cosmic conundrum. If you enjoyed this journey through the mysteries of the universe, don't forget to subscribe for more explorations into the wonders of space. Hit the notification bell so you never miss an update, and join me as we continue to unravel the questions that connect us to the infinite unknown. And as you look up at the stars tonight, remember that each one holds a story, a clue, and perhaps even an answer to the mysteries we've discussed. The universe is vast, but together we can begin to understand its secrets. Keep wondering, keep dreaming, and keep exploring. Until next time, this is your cosmic guide signing off.